Hello, my name is Gabriel Mutis. I am a student in the Math 3220 class. I'm in the 22nd discussion for fall semester of 2021. Today, I'm going to be talking about discrete and continuous random variables, specifically what they are, some differences between them, and show a problem relating to them. First, let's start off with what a random variable is. A random variable is a variable that can have multiple different outcomes without bias and associates that outcome with a numerical value showing the chances of getting it. Also, the brackets are just there for a reference page at the end so you can get an idea of where the info came from. Now, that's a pretty formal definition. A way I like to think about it is in terms of time. A random variable must have multiple different outcomes, like 3 or 5, without any one of them having anything rigged to make it occur 100% of the time. And each one of those outcomes must have a numerical value that shows its probability, like 1/6 for the cases mentioned before. Or another way to say it is that you can think of a random variable as a variable that can occur between any two numbers. Now, there's two types of random variables, one of which is the discrete random variable. Mathematically speaking, if we let omega be our sample space, a discrete random variable is a function x in that omega has real numbers that take on a finite set of values, a1, a2, all the way to a to n, or a countably infinite number of values. Or to use more English terms, a discrete random variable is a variable that has a sample space of a finite or countably infinite set of outcomes. Now, a pretty formal way to put it. Alternatively, another way to explain it is that a discrete random variable is a variable whose set of outcomes can be counted. These values are exact and do not have an uncountably infinite amount of numbers in between. Quick little side note for those who don't know, a countable infinity is a list of numbers that you can count for an infinite amount of time and you will eventually reach the end, while an uncountable infinity cannot be counted no matter how long you count for. Even if the random variable sample space is every integer from negative 10 to the 50th to 10 to the 50th, since it's only the integers, it can't be counted and is therefore a discrete random variable. The other variable type is the continuous random variable. In mathematical terms, a random variable x is continuous if for any function that has all real numbers and any two numbers a and b, with a being less than or equal to b, the probability of a being less than or equal to x being less than or equal to b is equal to the integer from a to b of f of x dx. The function of f of x must always be more than or equal to 0 for all of x, and the integer of the function of f of x from negative infinity to positive infinity must equal 1. To say it in a less mathematically heavy way, a continuous random variable is a variable that has an uncountably infinite amount of numbers in its sample space. It is literally impossible to know every single real number that is in the sample space of a continuous random variable. And for that last part of the slide, it was simply mentioning that the function of the random variable has to always be positive or 0, and that the area underneath the graph must equal 1. That means that if the random variable space for every number is every number from 0 to 1, since there are infinite amount of numbers in between them, the random variable would be continuous. Here's a small example list of what could be counted as a discrete and continuous random variables. Now, typically, I like to think of measurements when an extreme amount of precisions like volume, distance, and mass will be continuous, and on the other hand, the amount of something or a measurement without much precision like years, mass, and kilograms will be discrete. Here are ways to calculate mean and expected value, variance, and standard deviation for both variable types. In probability, when we refer to a random variable, we use capital letters. As you can see, there's not much difference between the two, with the biggest difference being the mean, with discrete using sum while continuous use integrals. Now, I want to show an example problem. A teacher records how long it takes for all the students to come inside the classroom by checking every minute from 1 to 7 minutes. They notice that the probability for all students to arrive by each minute is as follows. Assuming the probability is independent, find the expected time for all students to arrive and the variance and the standard deviation. Now, one of the first things you must determine is if the random variable here is continuous or discrete. In this case, because it's measured every minute, it is discrete. One of the things I like to do in these problems is make a table like this one with the y values and its probability. Now, first thing is to find the expected value. We must first set up the mean equation for our probability, then we must multiply each minute with the probability of that minute, which gives us 4.125 as our expected value. To find our variance, we need to first find e to the y squared, which is the same as finding our mean, but now squaring the minutes. Since we already know what e to the y is, all we need to do is plug it in and simplify. And to find the standard deviation, we simply square root the variance. Now, some of you will probably Wonder if this stuff actually has use in the real world? And the answer is yes. Discrete and continuous random variables play an important role in probability and statistics, since they are used in the creation of PDS and PEMFs. And everyday people use random variables as well in their day-to-day lives to guess their chances on an event happening. Thank you for watching my video. I hope you have a good one.